Welcome to qnawire.
To solve this question, we have to relate theta A with the refraction indexes of the liquids A, B, and C. We begin by remembering that a total internal reflection is the same as an angle of refraction of 90 degrees. Therefore, in this interface between liquid and glass, the refraction angle is 90 degrees. So we can apply Snell's law there. By using Snell's law there, we get that the refraction index of the liquid times the sine of the angle of refraction is equals to the refraction index of glass times the incident angle, which, according to my drawing, is theta C. Notice that theta R is 90 degrees, and the sine of 90 is 1. So this is equals to 1, and we get N is equals to N glass times the sine of the angle of incidence. Now, as you can see from the figure, we can do this, and the normals meet at a 90-degree angle. Therefore, you can see that theta C and theta B are such that they add to 90 degrees. Then, the sine of theta C is equals to the cosine of theta B. So, the index of refraction of the liquid is the index of refraction of glass times the cosine of theta B. And now we have to relate theta B with theta A. In order to do that, we have to apply Snell's law in this interface. By doing that, we get the following. The index of refraction of air times the angle of incidence, theta A, is equals to the index of refraction of glass times the sine of the angle of refraction, in this case, theta B. Then, notice that N air is equals to 1, so we can solve this equation for the sine of theta B. Then the sine of theta B is equals to the sine of theta A divided by the refraction index of glass. Using this equation, we can calculate theta B for each of these three liquids, and then using the value of theta B, we can calculate the value of the refraction index. Before doing that, let me organize my board. For liquid A, the sine of theta B is equals to the sine of 52 degrees divided by 1.52. And this results in an angle theta B of approximately 31.226 degrees. Then, the refractive index of liquid A is given by 1.52 times the cosine of 31.226. And this results in approximately 1.3. Now, for liquid B, we have the sine of theta B equals to the sine of 44.3 degrees divided by 1.52. This results in an angle theta B of approximately 27.3538 degrees. Then the refractive index of liquid B is 1.52 times the cosine of 27.3538, which results in approximately 1.35. Now, for liquid C, we have the sine of theta B being equal to the sine of 36.3 divided by 1.52. This results in theta B of approximately 22.922 degrees. So the refractive index of liquid C is 1.52 times the cosine of 22.922. This results in an refractive index of approximately 1.4. And this is the answer to this question.